All right, this is your review B for the logarithms chapter 6. First set of things are evaluate the logs without a calculator. So the log base 3 of 1/9. It's asking you 3 to what power equals 1/9, which is -2. 4x log 6 of 216. So I'm going to first do the log 6 of 216, which is 3. And 4x times 3 is 12x. The log 2 of 64 is asking you 2 to what power is equal to 64? And that answer is 6. Log 16 of 4. Now when the base is bigger than the of part of the log, the base is bigger than the of part, your answer is a fraction, probably representing a radical. So the square root of 16 equals 4, therefore the log 16 of 4 is 1/2. The log of 0.03, so the log of 0.03, we can't do that, but we could maybe look at it as the log of 0.01. It's very hard for me to write small. Times 3, which would be the log 0.01 plus the log of 3 using our product property. The log of 0.01 is -2 plus the log of 3, and that's pretty much all we can do without a calculator. The log 4 of -16, the of part of a log cannot be negative, so there's no solution. The log 2 of 8 to the 3x power. So I'm going to look at that as the log base 2 of 2 cubed, because 2 cubed is 8, to the 3x. And 3 times 3x is 9x. And the log 2 and 2 are inverses, so the answer is just the exponent 9x. And then 0.5e to the ln 4. The e and ln are also inverses, so I get 0.5 times 4, which is 2. The log base 3 of 0. Again, the of part cannot be 0 or negative, so there's no solution. Log base 2/3 of 3/2. 2/3 and 3/2 are reciprocals, so that means 2/3 to the -1 power gives you 3/2. Log 7 of 7 is 1. Log 100 is 2, because 10 squared is 2. Log 2 of 1/2 to the x, which would be 2 to the -1 to the x. Log 2 of that. And -x ends up being your final answer. ln e, again, those are inverses, so I get 2 times 5, which is 10. Log 4 of 64 is 3. 4 to the 3rd power is 64. Log of 1,000 cubed, well, that's the log of 10 cubed, which is 10 to the 9th. So the log and the 10 are inverses, so I get 9. That's -6. Log 5 of 125 is 3, so -6 times 3 is -18. And 4x times the log 3 of 1/27. That's 4x times -3, which is -12x, because 3 to the -3rd power is 1/27. The next is growth, decay, or neither, and if it's growth or decay, state the percent of increase or decrease. So if B is greater than 1, it's growth. If B is less than 1, or between 0 and 1, it's decay, and neither if A is negative. So if I go through these, this here is neither, because there's a negative in front. The other ones are all either growth or decay. So when I have the B term, that's looking at this term. That number is between 0 and 1, so it's decay. And the percent decrease, we need to think of that as our equations for word problems, 1 minus r. And so our actual percent of decrease is 60%, or 0.6. Because 1 minus r is equal to 0.4. We can look 1 minus r equals 0.4. So r is 0.6. And y is 4/3. Your b is 4/3. So that's greater than 1, so this is growth. And in this one, 1 plus r is equal to your 4/3. And so r is equal to 1/3, or 33%. This fourth one here is a little tricky. This actually is negative to the x power, or to the negative x power, which that could be 3 to the negative 1 to the x, which would be 1/3 to the x, which makes it decay, instead of our initial feeling of growth. So you have to be careful when the variables are negative, it's the opposite. And our percent of decrease is going to be 2/3, because 1 minus r equals 1/3. And so r is 2/3. As a percent, it would be 67% about. And this would be 33%. Number 5 here, 400 times 0.78 to the x. 0.78 is our b. That's between 0 and 1. So it's decay. And if 1 minus r is 0.78, so when it's decay, it's 1 minus r. When it's growth, it's 1 plus r. R is equal to 0.22, or 22%. And lastly, E. Well, E is always 0.718, but, or 2.718, sorry. So this is 2.718 to the 0.02x. So we kind of want to separate that and find out what 2.718 is to the 0.02 power. And I'll do that in my calculator really quickly. So when I do 2.718, which is e, to the 0.02 power, e to the 0.02, I get 1.02, which makes it greater than 1, so it's growth. And our growth factor is 2%, or increase. 1 plus what is 1.02? 2%, or 0.02. Let's move this up a little bit. Okay, finding the inverse of the equation. Y equals the log 2 of x minus 3. So the first step is to write your, switch your x and y. So x equals log base 2 of y minus 3. Now ask yourself, is the 3 inside the log? If the answer is yes, you convert it. If the answer is no, you move it. So I'm going to move it because that negative 3 is not inside my log. So I'm going to add 3. And I get x plus 3 equals the log 2 of y. And now I want to rewrite my log as an exponent. So it's 2, the base of my log is the base of my exponent. What it's equal to here, it becomes my exponent. So I get 2 to the x plus 3 equals y. Letter B, y equals log 4 of x minus 7, so x equals log 4 of x minus y minus 7. And the y is inside the log, so I'm going to convert it to an exponent first. 4 base of my log, base of my exponent. What it's equal to becomes my exponent, and that equals what's inside the log, y minus 7. And now I'll add 7 to both sides. So 4 to the x plus 7 equals y. Letter C, y equals 6 to the x plus 1. So x equals 6 to the y plus 1. That plus 1 is in the exponent, so I'll deal with it later. I need to rewrite this as a log. Log, base of my exponent becomes base of my log. Log base 6 of what it's equal to, x, equals my exponent, y plus 1. And then subtract 1. Log base 6 of x minus 1 equals y. And D, x equals e to the 8y plus 1. That plus 1's not in the exponent, so we're going to deal with it first. Minus 1. X minus 1 equals e to the 8y. That doesn't look like a y. Let's fix that. 8y. And then rewrite it. Natural log. E gets rewritten as natural log of what it equals to, parentheses, x minus 1, because the whole thing's all on the other side of the equal sign. And that's going to equal 8y. And then you have to divide by 8. So your final answer here is y equals ln x minus 1 divided by 8. Okay. So we're going to look at the next two equations on this slide. Make some room here. Number 4, without using a calculator, evaluate the expressions. Given log base, our log of 3 is approximately 0.477, and log of 5 is approximately 0.69. What I want to do is use my log properties, and I want to use any multiple of 10, because this is log base 10, or power of 10, and the numbers 3 and 5 to make the numbers inside the log here. So the first one is a log of 150. Log of 150 is 15 times 10, and 15 is 3 times 5, so I get 3 times 5 times 10, and that's the log of 3. With my product property, products become addition, plus the log of 5, plus the log of 10. The log of 3 is 0.477, plus the log of 5, 0.69, plus the log of 10 is 1. So now I have, I'm going to work down here and worry about that later. 1.69 plus 4.77, 2.167. So let's look at letter B, the log of 1 over 30. So we can think of this as the log of 30 to the negative 1, which will make my final answer negative, because negative 1 can go out front. Log of 30, which is negative log of 3 times 10 is how we get 30. That seems like the easiest way, in my opinion. You can't use 2 times 15 because you don't know log of 2. So that's minus the log of 3 plus the log of 10, which is negative 0.477 minus 1, distributing the negative, so negative 1.477. The log of 0.005, let's just move here so we have more space. The log of 0.001 times 5. and that's the log of 0.001 plus the log of 5, which is 0.69 is the log of 5, the log of 0.001, 1, 2, 3. Look at that, 1, 2, 3 decimal places, so that's negative 3 plus 0.69, which is going to be negative 2.31. Part D, the log of 300. Log of 100 times 3. That's how I see it right away. And that's the log of 100 plus the log of 3, which is log of 100 is 2, plus 0.477. So you get 2.477. And lastly, log of 5 divided by 3 is the log of 5 minus the log of 3, which is 0.69 minus 0.477. And break out those subtraction skills. So we get 0.213. So that's how you do those. You always want to look at the base of the log and use any power of that number and then what you're given. Okay, so if you need to write any of that down, you need to pause it because I'm going to move it out of the way for us so we can do the word problem. There are initially 4,000 bacteria in a culture, so A equals 4,000. If the number of bacteria double each hour, how many hours would it take for the culture to have 60,000? So doubling gives us actually the factor. The growth factor is 2. So the B in this case is 2, which is 1 plus the rate. It's increasing at a rate of 100%. So my equation is 4,000 times 2 to the t equals y. And I want to know what t is when y is 60,000. Equals 60,000. So we're going to divide by 4,000. And those zeros cancel. 60 divided by 4 is 15. So 2 to the t equals 15. And we get the log base 2 of 15 equals t, if we're going to rewrite it. And that's the log of 15 divided by the log of 2 equals your t, which is t equals 3.907 hours. Our next word problem is a boat was bought for $95,000 and depreciated at an annual rate of 6.25%. So this is your rate. This is your initial value. How much was the boat worth in 6 years? How many years would it be when the value of the boat is 40,000? So it's asking 2 questions. Let's write our model based on y equals a times 1 minus r to the t. And I'm using minus because the key depreciated means it's decaying. So y equals 95,000 times 1 minus 0.0625. Please don't mess up the 2 decimal places on that, or yeah, the 2 decimal places on that. So you get 0.0625, not 0.625. And 1 minus 0.0625 is 95,000 times 0.9375 to the t power equals y. Now I can solve both questions. How long will it take for it to be worth, or what will it be worth in 6 years? We plug in 6, 95,000 times 0.9375 to the 6th power, and we enter that into our calculator. Make sure when you do in your calculator, we use the order of operations. We're going to raise 0.9375 to the 6th power first. I get 95,000 times 0.6789. And I get $64,498.74. So that's after 6 years. Now the second question was, how long will it take to be equal to 40,000? So I don't have enough space there. Let's move this over a little bit. 40,000 equals 95,000 times 0.9375 to the t. I'm going to divide by 95,000. And when I do that, that equals 0.9375 to the t power. And 40,000 divided by 95,000 is 0.4211. And now I'm going to rewrite this as a log. Now this is an equation where you got all these decimals. It might be better to take the log of both sides. So let's do that way. Log of 0.4211 equals log of 0.9375 to the t. You are totally welcome to rewrite it as a log if you want. I'm just showing another way to solve this. Sometimes the decimals can confuse people, so you want to use a method that you'll get it right every time. So we'll divide by the log of 0.9375. What happened to this t? The t came in front because of my power property. So divided by the log of 0.9375. And the nice thing about this is it sets up our calculator for us already. So the log of the numerator divided by the log of the denominator is 13.40 years. So it would take 13.4 years for the boat to be worth $40,000. Okay, I've cleared up the screen for us so we can look at solving these equations. And we're going to use no calculators for these. So number 7 says the log of x plus 4 equals 8. So the plus 4 is not inside the log, so I'm going to subtract 4 from both sides. And I get the log of x equals 4. Now remember, I have several options here. I can rewrite it as a log, or I can exponentiate. So I guess that's 2 options. But this is log base 10. So if I rewrite it as a log, it becomes 10 to the 4th power equals x. And x equals 10,000. Number 8, 4 to the x minus 9 equals 4. Remember that 4 has a 1 on it as an exponent. My bases are the same, so I can write the equation x minus 9 equals 1 and solve that. So x equals 10. Number 9, log base 6 of x minus 2 equals 3. Let's rewrite this as an exponent. 6 to the 3rd power. 6 to the 3rd equals what's inside the log, x minus 2. So as a rule of thumb, whatever starts on the same side of the equal sign, when you rewrite it, should not end up on the same side of the equal sign. So the 6 and the x minus 2 have to be on different sides of the equal sign if you rewrote it correctly. And then 6 cubed is 216 equals x minus 2, add the 2, and x equals 218. And number 10, 5 to the x plus 1 equals the square root of 125. That's 125 to the 1/2 power. 5 to the x plus 1. I can still write that as 5 cubed to the 1/2 power. So multiply my exponents, and x plus 1 must equal 3/2. Subtract 1, and x is 1/2.